This is the roller coaster simulation. The purpose of this activity is to observe the transformation of mechanical energy. So I will be posting this video as a reference, but also there is this simulation. You can see that I have that opened up into the window on the right. And I did provide a couple of other videos about conservation of energy and how to calculate the forms of mechanical energy. All right. So you can see here, use the simulation of the cart along a roller coaster to answer the following questions. So the first part, there's 5 different pictures, right? Scenario 1, 2, 3, 4, and 5. And basically, each of these are going to set up those scenarios. So it does tell you how to do that, but also I just figured it'd be easier to provide a little reference up there to show you how to do that. So the first one is you just pull that up, and I want to see the show velocity vectors, show force vectors. And then I just want to play, right? That's it. So the question just asks you, I mean, what's happening to the gravitational potential energy of the cart? The mechanical energy, kinetic, and gravitational potential energy of the cart as it goes along this track. So you can see what's happening there on this one. So you can just be able to answer those questions. Next up, scenario 2. All right, so now what we're going to do is we're going to click on the ramp. Oh, sorry, the ramp. Oh, the ramp. Okay, so we're going to have to make this ramp here, right? So it is a little tricky, but it's just pretty simple just to do that, right? The key is you want this initial point higher than this ramp on in the middle, right? So I want to see the velocity vectors and I want to see the force vectors as well. So then I'm just going to answer this question and say, well, does it go over the ramp when I set it up like this? There we go. What's happening to the kinetic energy and the gravitational potential energy as it goes along, right? Why is it able to go over the ramp? So then what I'm going to do is I'm just going to stop at the next scenario is I just lower this initial starting point, right? I want to, let's see if I can, let me reset it. There we go, right? So now I want to know, well, will it get over this ramp? Why or why not, right? Why or why not? Good. All right. Next one is I want a loop. So it's already set up. I want to see the velocity and I want to see force vectors. This one's asking about the normal force, and it's represented by that capital N. The normal force, when is the normal force of this cart the most as it goes down this ramp? When is it the least, right? When is it the least amount, right? So, yeah. So just look at that force vector, and you can answer the questions based on that. The last one, though, is we need to go back to the ramp. There we go. And I want to see show velocity. I want to see everything, but I also want to turn on the track drag, right? So just like you'll be able to see what happens when I do this. Just see what happens to that mechanical energy as I let this this cart go down with the drag, so we can see that drag, and look what happens to that mechanical energy, right? So just like what's happening to it, right? Where is that energy going? All right, now the conclusion questions, you can ask a lot of conclusion questions, but the 2 big ones about learning about roller coasters is, why is the tallest point on a roller coaster the initial drop, assuming the cart starts at rest, and when is the cart moving the fastest on a roller coaster? How is this known, right? So this is just a good simulation about introduction to like roller coasters. Before we even put numbers to anything, this just helps us visualize what's happening to the mechanical energy of a roller coaster as it goes along the track. Once again, this is the simulation, the roller coaster simulation.